Hey folks, welcome back. In this video we're going to go over question 1 from the 2021 SQA Advanced Higher Physics exam paper, so let's get going. Now question 1 says, during a roller coaster ride, a train is moving along a track as shown in figure 1a. So there's figure 1a there, and at time t equals 0, the train reaches a straight section of track. It takes 4.0 seconds to move over this section of track. The horizontal velocity Vh of the train over this section of track is given by the relationship Vh equals 8 plus 4t squared minus 2/3 t cubed, where Vh is in meters per second and t is in seconds. It then says, using calculus methods for part A, determine the horizontal acceleration of the train at time t equals 4.0 seconds, and you'll see there's 3 marks available for this. Well, remember we're given an expression for horizontal velocity, so to find the horizontal acceleration, we need to differentiate. So, differentiating v with respect to time t, we have a is equal to dv by dt, which remember is just an equation on your relationship sheet, and we can say that's the same as writing d by dt of 8 plus 4t squared minus 2/3 t cubed. In other words, just differentiating this expression with respect to time. So if we do that, remember differentiating involves bringing the power down and multiplying by the number in front, and then taking 1 away from the power. So if we've just got the number 8, that's a constant, so that becomes 0 when we differentiate it. When we have 4t squared, that will become 2 times 4 times t to the 1, so that will be 8t. Minus 2/3 t cubed. If we bring the power down there, that will be minus 2 times 3 over 3, which is minus 6 over 3, which is minus 2, and then we take away 1 from the power, so that will be minus 2t squared. So we have a equals 8t minus 2t squared. And remember, we want to find the horizontal acceleration at this given time, so we want to now substitute the time value. So we have a equals 8 times 4.0 minus 2 times 4.0 squared. And you can do that either in your calculator or in your head. So we have 8 times 4, that's 32, minus 2 times 4 squared. So 4 squared is 16, and 2 times 16 is 32. So we have 32 take away 32, which would give us 0 meters per second squared. For part B, it says determine the horizontal displacement of the train at time t equals 4.0 seconds. And again, we have 3 marks available here. Well, remember we were given an expression for horizontal velocity, and if we want to find the horizontal displacement s, then we need to integrate both sides of the expression. So we want to integrate v with respect to time, so we can rewrite v as being equal to ds by dt, which is just an equation from the relationship sheet, and we can say that's equal to 8 plus 4t squared minus 2/3 t cubed. Then we can ignore the v part and just integrate both of these terms. So we have the integral of ds by dt is equal to the integral of 8 plus 4t squared minus 2/3 t cubed dt. So integrating velocity will just give us s on this side, and then integrating, remember we want to raise the power by 1 and divide by the new power. So we have 8t plus 4t cubed over 3 minus 2t to the 4 over 3 times 4, plus c, which is our constant. We can then tidy this up a bit, so we have s equals 8t plus 4t cubed over 3 minus t to the 4 over 6 plus c. And then to find out what this constant c is, we need to consider the initial conditions, which is just what happens when time t equals 0. Well, at time t equals 0, the train is not going to have moved, so its displacement s is equal to 0. So if we plug in t equals 0 here and s equals 0, then we get c equals 0. So we can rewrite s as s equals 8t plus 4t cubed over 3 minus t to the 4 over 6. Now remember, we want to find the horizontal displacement at this given time. So lastly, we want to substitute the time value. So we have s equals 8 times 4.0 plus 4 times 4.0 cubed over 3 minus 4.0 to the power of 4 divided by 6. And putting that into your calculator should give you an answer of 75 meters. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.